ITD program launch, which is Industry Technology Demonstration. The presentation is being made by Brian Mintz of Phoscrete. Brian is a general manager for Phoscrete Corporation.
Hi everybody, thank you for coming. As mentioned, my name is Brian Mintz and I'm general manager with Phoscrete. We're here today to talk about the ITD program. Ed Welsh is I don't see Ed in the house over here, so while I mentioned that he is moderating this, I may have to step in his shoes. Also with me is Lorella Angelini, who's a civil engineer, who's a consultant in the program, and representing owners and agencies is Walt Peters, PE, from Oklahoma DOT. ITD it stands for Industry Technology Demonstrations, but I prefer to call it Innovative Technology Documentation. Anything that helps us figure out or understand an acronym better in our industry is certainly helpful. Again, as I mentioned, Ed Welsh is the working group chair of this working group, and the work team are me and Lorella. This is the one slide I'm going to read for everybody. I'll try not to read them all and keep it interesting. Industry Technology Demonstrations is an AASHTO TSP2 field demonstration program designed to introduce innovative materials and technologies, including services, for bridge and pavement preservation to DOTs. ITD is open to other owners, including municipalities, airports, military, port authorities, and private industry. ITD is a collaboration of 4 parties. You have the owners, state and other owners. You have manufacturers. The manufacturer is responsible for proposing the field evaluation of an innovative technology and engages the independent consultant. The consultant is an independent third party that implements the program. And finally, AASHTO TSP2 defines, reviews, and supports the ITD program and gives authorization to field test a technology or a service. The owner's goals are to learn about innovative products and technologies through the field applications and share that information, transfer it to this information about the technologies throughout the 50 DOTs and other interested owners. The other party's goals, AASHTO TSP2, I'd like to note that AASHTO currently has 2 other programs. One is NetPEP, the National Testing Product Evaluation Program, and that is designed to be doing product and laboratory evaluations and plant inspections. And then APEL is an innovative product evaluation list that involves evaluation and lab testing of new, innovative, and/or proprietary engineered transportation products, but APEL is not intended for evaluations for materials or specifications that already exist. ITD adds value by it adds value and not duplication to these programs by making available information about innovative technologies, focusing on field experience across multiple installations in varying environments. The manufacturer's goal is to field test innovative technology in a neutral, unbiased environment. We want to share credible experiences of successful products or services. The work scope is to promote the development and/or adoption of best practices for bridge management systems to extend the service life of bridges and demonstrate the value of preservation. We also want to develop general guidance and examples to help practitioners nationwide identify best practices for bridge management systems that meet the needs of agency and establish a process that makes implementation less intimidating. We also want to monitor and share the solutions as they evolve. Now I'd like you to meet Professor Henk Jonkers of Delft University of Technology in the Netherlands. Professor Jonkers has come up with an entirely new way of giving concrete a longer life. The bioconcrete is mixed just like regular concrete, but with an extra ingredient, a healing agent. It remains intact during mixing, only dissolving and becoming active if the concrete cracks and water gets in. Here you see this bioconcrete actually healing the cracks in concrete. Innovative? For sure, wow. So let's imagine, what do you think Professor Yonkers is going to do when he travels to the US and he visits his first DOT? What's the first question they're going to ask? Is it on the QPL? Well, contractors and DOTs prefer to use approved products. If there are material failures, that means that they're not liable. Then the next question he's going to ask is, who else is using it? Nobody wants to be the guinea pig. They want to see references. Let's try it out and wait and see. It seems that every state is Missouri, the show me state. And finally, wait, watch, repeat 50 times, or the manufacturers of the innovative technologies will ignore most of the states and focus on the ones that are most receptive to the new technology. There are several areas that we have a problem in bringing new technology to market here amongst our owners. The first one is regarding documentation. I've been on job sites where the deck is full of bubblegum patches from different products over the years. Some are holding up, some aren't holding up. Nobody did a good job documenting the repairs or following up, and new crews are replaced by old ones, so nobody really knows what's what. Bias. If I were to show you reports of 10 successful repairs provided by the manufacturer, you can assume that that manufacturer isn't going to open up their case study documentation and show you areas where they had failures or issues. One strike and you're done. If you as an owner tried this product and it didn't work in your one single application, the odds are you might never want to try it again. And finally, difficulty of sharing amongst agencies. I'm aware of a company that sold a repair product into several districts in one state. After less than 6 months, the repairs began to fail. Finally, word got around that state that the product was no good. So it was rejected and it wasn't used in that state. A few months later, I'm at a conference in another state, and the DOT crews are telling me that they're starting to try that same material. And finally, the long process. I see Greg Freeman and Merritt Hansen in the room. If you guys could raise your hands. I asked them, and I reached out and asked them about QuickBond. They cut their teeth in California for many years and are now branching out across the United States. I asked them to share a quote as it relates to the problem of the slow road to credibility in our industry. And our infrastructure cannot afford to wait another 35 years before widespread deployment of the next great innovative products and services. So ITD is a faster path to the best solutions. It helps industry speed the best solutions to market and saves the agencies the cost of wasted time and resources on unsuccessful technologies. This is a slide that shows an article that was in New England Construction Magazine. 3.5 years ago, MassDOT was one of the first invited agencies to hold a demonstration, and they selected a bridge on I-190 near Exit 1 in the city of Worcester that crosses over the Providence-Worcester railroad tracks. And you have to know how to pronounce Worcester. Is Mohammed Nabulsi happen to be in here? Hi there, Mohammed. This was your project and your crew. I have a bunch of key MassDOT personnel were on staff, including Mickey Spillane, who was the assistant bridge engineer. Phoscrete Corporation's representative was Don Wiesel, and he's our installation application specialist, and a young Ed Welsh, PE for bridge preservation for the NCPP. He was on site as well to represent the AASHTO TSP2 program. So the manufacturer's involvement is pretty straightforward. We provide on-site installation support. We contract and compensate the consultant to document the information, and we're responsible for following up on all the inspections, all the follow-up inspections. The independent consultant is really the key to the success of this program because the independent consultant will document all of the installations, the good ones, the bad ones, and the ugly ones. And finally, the owner's commitment is to identify the location, to purchase the material used for the repair because they've got to fix it anyway, to provide mobilization and installation, and to perform scheduled inspections. From the manufacturer's experience, and again, Phoscrete's MALP technology was the guinea pig for this ITD pilot program. Our magnesium, alumino, liquid phosphate, concrete repair materials are cementitious materials that don't use Portland cement and don't use water. Advantages include very rapid setting, as quickly as 30 minutes traffic ready, ability to work in sub-freezing temperatures because the freezing point of our activator is -20 Fahrenheit, and corrosion mitigation because Phoscrete cures acidic and counteracts the halo effect. With our program, we wanted to get follow-up inspections at 30 days when shrinkage cracking is most likely to appear, then again at 6 months, 1 year, 2 years, and as long as 5 years. We launched our ITD pilot program 3.5 years ago. And fine-tuned the process until we believe it's finally effective and good to go. What we learned is the owners are receptive, but don't make it overly complicated to collect data and get an upfront commitment from the owners to agree to perform the follow-ups over the course of time. The follow-up inspections was one of the most difficult parts. It's better, from our experience, to get the consultant involved from the very beginning so they have a relationship with the owners and know when it's time to get those follow-ups.
I will briefly inform of a MALP concrete application that I supervised as a part of the ITD program. Okay, perfect. So, as I said, I will inform you about an application of MALP concrete, an application that I supervised in Minneapolis as a part of the ITD program. The purpose is just to give you an example of application and supervision for this program. Here we are downtown Minneapolis in a parking garage that is owned by City of Minneapolis. It is a post-tensioned structure built in the 70s. Deck has been patched many times and the patches are protected with a polyurethane membrane. Minnesota is cold and many de-icing salts, even the most aggressive ones, are used. The application entailed just a concrete repair, horizontal concrete repair, 2 patches that in the slides I called square and trapezoid based on their shape. It happened in December. It was at the end of December in the morning. The temperature was between 29 and 31 Fahrenheit. There were quite a lot of people at the application. 4 people from the City of Minneapolis, 2 engineers and 2 people who were expert in application. The technical consultant from Phoscrete, and myself as an independent consultant. The size of the patches was, the trapezoid patch was 2 by 2 feet, 4 inch deep, and the bars were free, so the concrete was removed beneath the bars, while the square patch was almost the same area, 2 by 2 feet, but less deep, so the bars remained partially embedded in the concrete. Classical procedure for concrete patching, so cutting the edges, clean the rebars, concrete surface profile 5, and dry concrete, because this is an important requisite for MALP concrete. 45 seconds up to 1 minute of mixing time with an electric drill and an auger, and 3-5 minutes time between the first and the second batch. It took 2 batches for patch, and didn't take more than 15 minutes to complete each installation. 3 people working, 1 at the mix, 1 at the pour, 1 for troweling. The installation was completed between 10 and 11 a.m. At noon, the parking was reopened to traffic. Those 2 areas were reopened to traffic. Then I came back 1 month later. It was even colder because we were in January, and everything was fine, except that the square patch had a sort of dark gray area at the center. It looked as if there was a puddle of water, and we couldn't explain it. It was only in one patch, not in the other patch. Then we tested adhesion with the hammer and the drag chain. At a 6-month inspection, the dark area disappeared. Again, testing adhesion with the hammer and drag chain. No debonding at the edges, no cracks. After 1 year, we start seeing something different. For example, the score patch showed some fibers on the surface, probably due to the abrasion. And the trapezoid patch showed some minor scaling, probably due to scaling by the icing salts. In both cases, no cracks, no debonding. At 2 years inspection, we finally saw one crack. It was in the trapezoid patch, a little hairline crack, about 3-inch long. No debonding, and the sound test. This time we didn't have the hammer, we did with the rod. In both patches went well. Now the goal is to go back in 3 years for the 5-year inspection. City of Minneapolis is happy with this installation. They are not going to protect the patch like they do with the other technologies, because even the patch is not particularly aesthetically pleasing, it's just gray concrete. For them, it's a big saving if they can avoid covering the patch with a membrane. And they also wanted to evaluate thoroughly the durability of this MALP concrete Phoscrete technology without any protection.
Thank you very much, Lorella. Next, I'd like to invite Walt Peters. He works for Oklahoma DOT and Bridge Division. He's an assistant bridge maintenance engineer, graduate of Texas Tech University, married with 3 children, and he's up 2 grandchildren on me.
So from the owner's perspective, I'm just see a lot of salesmen. Everybody's got great products. Sometimes we refer to it as snake oil. Sometimes it's great stuff. So I need to figure out what works. And to do this, we have some bridges with soffit issues in our state. We used a lot of bridges for a while. We put epoxy green steel on the top layer, and we put black steel on the bottom layer. And inevitably, we have these 5-foot openings in our TRL or our parapets, and a lot of moisture runs under the bridge, and the next thing you know is you're losing your concrete on the underside of the rail. So I thought this would be a good challenge for this product. If it's going to work in that application, it probably work in a lot of different of the corrosion issues that we have in my state. So I understand that this product has a pretty low pH and that the halo effect is prevented mainly because it's going to have a lower pH than the remaining material, even if you got a little bit of carbonation or something. So we want to put them to the test here. In Oklahoma, western Oklahoma, it's really kind of in the middle of nowhere, very sparse population. But we have a maintenance yard out there in Shattuck, Oklahoma. It's in the middle of nowhere. And so we met there. The Phoscrete guys came and met us, and they demonstrated their product, gave us a little instruction on how to properly apply it, which we're grateful for. So in this demonstration, he cut a garbage can bottom off, and he mixed some Phoscrete, filled it in the lid there. It got really, really hot. And then after a while, when it cooled off, he mixed a secondary batch, and he poured some little secondary pores there, which he could use as handles to lift it up to demonstrate the bond, which that was impressive. So here we are at our bridge site. this bridge over the Canadian River, just for your information, is probably about 3,000 feet long. I didn't look it up. It's on US 283. It's about 50 miles north of Interstate 40, and it's about as far west as you can get in Oklahoma without going into the Panhandle. Like I said, we had a little problem with our cantilever here. We're seeing a lot more rebar than I want to see. And that opening's 5 feet long, so you go about 2 feet past either side, you're ending up with about 10 by 2 foot section that you need to fill, and probably in places it has about 4 feet, 4 inches loss out of our 8-inch deck. Not everywhere though. So I was looking at this, some of the pictures, and I could even see some of the bar chairs where that supported our deck originally. So that exposure, the bars are kind of hanging down. This is going to be a good challenge for these guys. So the next thing, I got this picture of Wendy Love. She's out of our Buffalo Division 6 office. She was doing the surface preparation, which in this case consisted of using a small grinder. And she did a good job, I think, but we didn't spend a whole lot of time on surface preparation. So the next thing we see is the guys taking the Phoscrete VO out of this little pail. They're taking it up in their hands, and they're physically pushing it up into this deck. And we got 2 Phoscrete guys working. They were great workers. And 2 of our ODOT personnel, and we had numerous supervisors out there, typical for a demonstration project. But anyway, we're trying to learn something here. And it took them maybe 3 hours or so. The way we did this was very labor intensive. Had we used shotcrete, it would have gone a lot faster. Nevertheless, we got it done. So after it was done, it got pretty late the day we did it in March. So I came back in April and looked at the repair. And for one thing, I was very pleased to see that they reestablished the drip bead. And it looked like they did a pretty good job of putting a pretty good volume in concrete when you consider it's being done by hand. And they kind of reestablished our soffit there. I did observe one concern, and that was I saw a few cracks, but interestingly, the cracks were limited to the curb area, the side of the deck, and kind of under the deck up to where that drip bead was. The cracks measured about 0.03 inches, maybe some a little more, some less. And it was just like a 1 foot long by 4 or 5 inch wide area. It was very localized. And I don't know if that's shrinkage or... I came back a year later, so it was done in 2017. I came back in February of 18. It was originally done around early March of 17, so that's approximately a year later. It just didn't look much different. I was seeing exactly what it was the previous year. So that was impressive. Also, I was somewhat thankful. Here we see some more pictures, and look in either direction, it just looked pretty much the same. Here I show a comparison, and other than being a little darker, perhaps from water staining, it really looks exactly the way it did April 17 to February 18. So for comparison's sake, I took picture of a kind of adjacent area that showed some rust stains, primarily in some bar chairs, and I see enough efflorescence and cracking to think we're going to be repairing that pretty soon, one way or another. I do think if Phoscrete works good there, then I might want to try it in some other places, like on some pier caps and on some of these pre-stressed beam ends where I got the very end of the beam with exposed strands that I thought this low pH material might have really good potential.
Our ITD challenges, The manufacturer needs to collect the data, to train properly, and to report the problematic installations. The consultant needs to collect the pertinent data, not too much, because if it gets too much information, it's not helpful. Establish a relationship early with the owner, so when it's time to schedule inspections, that they have that communication going. And finally, the agency needs to make a commitment to follow up over a period of time so that we can document this very well. We're ready to do our ITD program launch and open this program up to other manufacturers, other industry people who are providing products and services that are innovative and want to find an avenue to document and share that information with the TSP2 organization and around the country. So our first step is we want to reboot the MALP ITD, and we're looking for 6 to 12 owners. We've talked to several people at this meeting who want to participate now that we've learned over the course of 3 years exactly how we do this. And as mentioned, it's opened up to other innovative products. There is a TSP2 working group. There's going to be an application posted on the website. Please feel free to contact me, Ed, or Lorella if you have a product or service you would like to bring into the ITD program.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.